Okay, so in section 3-3, we're again dealing with systems of inequalities. We've done inequalities before. That's when we shade the graph, right? But now we're doing systems of inequalities. So we're going to have multiple inequalities to graph. Now, in our systems, we're only ever going to be dealing with 2 inequalities at a time. Obviously, you could imagine having 3 or 4 or 5 inequalities to have to deal with at a time. Same with equations. We won't do that in here. All right? So, as you know, when we graph an inequality, I'm just going to do a little sketch up here. When we graph an inequality, we shade part of the graph. That's, the answer, right? Everything that's, in this case, since it was a solid line I drew, everything on the line and in the shaded region is part of the solution. Well, all we're doing now is drawing a second inequality on top of it. So we're drawing another inequality on top of it, and then anything that is in both shaded regions is our solution. So everything in the red is not the solution to the system. Everything in the blue is not the solution to the system. Everything that is on this part of that line up to this dashed line and in the overlapping shaded parts. That is the solution to the system, because that is what's in both solutions, the red and the blue. Okay? Yes. So we graph our 2 inequalities. I have a blue one I just sketched, right? And I have a red one that I just sketched. Let me, in fact, even zoom up here. Okay? And so if you notice, the blue one has a solid boundary that I drew. The red one has a dashed boundary that I drew. Okay? The solution to the system, meaning both of these together, the solution to the system is going to be where these 2 overlap. And so notice, the red shading includes this part of that solid blue line. So everything on that solid blue line is a part of the solution. Okay? But over here we have the dashed line that's part of the blue, in the blue shading part. Well, those dashed points on the dashed line are not part of the red solution. So everything up to those are part of the solution. And then everything where the blue and the red overlap. Everything that's where the shading overlaps. Okay? So the solution to the system is the stuff there in black. Not the red or the blue. The stuff in black is the solution to the system of inequalities.
Do we only shade the black?
For your final answer, yes. I'll show you how I want you to work the problem. But yes, for your final answer, you're just shading the solution to the system.
Right.
Okay? All right, so let's take a look at an example. Here's our first one. So we have 2 lines for our boundaries. The second one is already written in slope-intercept form, so we can go ahead and do that one. But before we do that, let's go ahead and rewrite the first one. So inequality number 1 is 2x minus y is greater than or equal to -3. And I want to get it in slope-intercept form, so I'm going to subtract 2x from both sides. So negative y is greater than or equal to negative 2x minus 3. And I don't care what negative y is, I want to know positive y. So I've got to divide everything by a -1. And so I now have positive y is less than or equal to positive 2x plus 3. That's now my boundary. I can go ahead and graph that inequality. I'm going to do this one in red. So let's see. I have a y-intercept at 3. And my slope is 2. So that means I go up 2 to the right 1. I'm going to go all the way across my graph with that, both directions. All right, when I draw this boundary, am I going to draw it with a solid or a dashed line?
Solid.
Solid line, because it says less than or equal to. All right, and now I need to decide which side to shade. So I use my test point 0, 0. And I'm going to plug it back into the original. So I have 2 times 0 minus 0 is greater than or equal to negative 3. 2 times 0 is 0. 0 minus 0 is still 0. Is 0 greater than or equal to negative 3?
Yes.
That is true. So I'm not going to shade that whole side. What I'm going to do is I'm going to simply give myself arrows telling myself that I am shading this side. So now we move on to the second inequality. I'll do this one in blue. But the second inequality is already written in slope-intercept form for us, so that's nice. So I can go ahead and go to 1 for my y-intercept and count a slope of negative 1/2. So down 1, right 2. And again, go all the way across your graph in both directions. Is this going to be graphed with a solid or a dashed line?
Solid.
Again, solid line. Okay, so there's that. And again, we have to decide which side to shade. So I'm going to test 0, 0 again. So that gives me 0 is greater than or equal to negative 1/2 times 0 plus 1. So negative 1/2 times 0. That's 0. Plus 1 is 1. So 0 is greater than or equal to 1.
Shade above.
That is false. And so therefore, yes, I'm going to shade this side.
Technically, you're talking about the line, but if you were going to shade that little, like, 90 degrees right angle.
Well, all problems like intersect and like
That'd be
that,
quadrant.
or like something like that.
Yeah, it could. Some might be parallel lines you shade in between those regions, or, yeah, absolutely. Absolutely. And so in this case, now we're not done yet, folks. We're not done yet. I've just shown where I'm shading. The answer or the solution set for this system is going to be everything that's on this part of the red line, everything that's on this part of the blue line, and everything in this region. Because that's where the shadings overlap, right? Right, that's where the red overlaps, because the red gets shaded all this side. The blue gets shaded all up this side.
So if blue was shading the other side, we'd be shading that.
If the blue was going the other way, we would shade this bottom part here. Yep, absolutely. Okay, let's do the one right next to it here. Working the one right next to it here. Again, our first equation here, and I'll do mine all in black since many of you are just using pencils, so as you should be, by the way. So I'll show you what you should be doing on your work. So equation number 1, we have x plus 2y is less than or equal to 4. So subtracting x from both sides, 2y is less than or equal to negative x plus 4. And now dividing everything by 2, y is less than or equal to negative 1/2 x plus 2. We can then graph that boundary. The y-intercept is at positive 2. Slope is negative 1/2. So I'm going down 1, right 2. And up 1, left 2. All right, do I graph this with a solid or a dashed boundary? Solid. All right, and we're going to go ahead and try a test point. So 0 plus 2 times 0 is less than or equal to 4. Yep, 0 is less than or equal to 4. That is a true statement, so we're shading this side. Okay. All right, so now looking at the second equation, equation number 2, already in slope-intercept form for us. So I'm going to go to -1 for my y-intercept. I need to go down 1, right 1 for my slope. I'm going to go clear across my graph. I'm going to start going down 2, right 2, just to make it a little quicker. Make sure to go the other direction as well.
So you just go down 1,
Down 1, right 1, or up 1, left 1. Yep. Again, solid or dashed? Solid. All right, so there's that graph. Now, again, we need to use a test point. So testing equation 2 is 0 greater than or equal to -0 minus 1. Well, -0, there's really no such thing as -0. It's just 0 minus 1 is -1. 0 minus 1? No, because this is just 0. 0 minus 1 is -1. And so 0 is greater than -1. That is true. So I'm going to shade everything on this side of that boundary.
So you shade that acute angle.
All right, so yes, our answer is then on those two boundaries and everything in here.
Like nothing above or anything, it's just under.
Right, because up here, I'm assuming this is what you're talking about? Yeah, because this boundary goes this way, this boundary goes that way, so they kind of miss each other in that little area up there. Yep. So a couple of special situations that could arise. All right, we could have a situation where you have parallel lines and these parallel lines are shaded towards each other. Okay, well, if that's the case, then your solution is just everything between. You're shading between the parallel lines. Okay, well, we could have a situation where, again, we have parallel lines, but they're shaded away from each other, in which case there's no solution. Okay, and then there is yet another one that you brought up. What if we have, and I'll try to do it this way so you can kind of tell what I'm talking about. What if we have some line here, and then we have another line, oops, I meant to make that smaller, right on top of it. They're the same line, right? Careful. If they are shaded on the same side, then it looks like just one regular inequality graph. That whole side is the boundary, and that whole side is your solution. Okay? And there's another case, though. What if they are, again, the two lines are the exact same line. So there's one, here's the other. Okay? So there's my two lines, but the black one is shaded on this side, and the red one is shaded on this side. There is a solution to this. The solutions are only the points on the two lines. There's no shaded region, right? There's no shaded region. The only solutions that work would be the points on that line. Okay? So please, please, please remember, we have these three situations, okay? But when we're talking about inequalities, your only options are infinite solutions or no solutions. Because every inequality is going to have infinite solutions. That's why we shade a whole region. Right? There are infinite number of points that work for that inequality. So for linear inequalities, you're never going to end up with just one solution at this point is where it works. Okay? You're always going to have either a region of infinite points or no solutions if it happens to be this situation. Okay, on the back side of your notes here, it's possible that we're not going to deal with linear inequalities. We could just as easily deal with any inequalities or inequalities involving absolute values. So let's talk about this system. In this system, equation number 1 is a line. Y is less than or equal to 3. By the way, is that going to be a vertical line or a horizontal line? It's going to be a horizontal line. Where does it cross the y-axis?
At 3.
At 3. So we go up 3, and we're drawing a horizontal line. And it should be a solid, right? Because this is less than or equal to.
Yes, sir.
Please watch out for that. I know all the examples we've done so far have all been solid lines. But watch out for that in your homework. Make sure you're actually drawing solid lines when appropriate, or dashed lines when appropriate. Okay, so we have that. Now wait a minute, I haven't shaded yet. Which side am I supposed to shade for that? Up or down? Down.
0.
Y is less than or equal to 3. 0 is less than 3. So I shade this side. Okay, so we got that one done. Now looking at the second inequality, which in this case is an absolute value. So for that second inequality, where is our vertex located? 1, 0. What's in there with the x is the x coordinate. And remember, x is hexed, y is y's. Right? We were plugging into, just as a reminder, we're plugging into or figuring this out from y equals a times the absolute value of x minus h plus k. H and k give us the vertex. Okay, well then what's the slope of the right side? And that a value is positive, so does that mean our v opens up or it opens down? It's going to open up. The a value is positive, it opens up. All right, so graphing that absolute value, I go to 1, 0, which is right there, and I'm going to count a slope on the right side of 1, up 1, right 1. I'm just going to start going by 2's to make my life a little easier. And I want to rotate that or fold it to the other side, right? So mirror that to the other side. I start getting these points.
She only shade what is that little v.
All right, so well, we got to find out here. Our test point 0, 0, is that inside the v or outside the v?
Outside.
That's definitely outside the v. So I'm going to plug in 0, 0. 0 is greater than or equal to the absolute value of 0 minus 1. So 0 is greater than or equal to the absolute value of negative 1, which is 1. 0 is greater than 1?
False.
That is false. And so I am shading everything that's inside the V. Well, first off, I forgot to draw my boundary on this V. Solid or dashed? Solid, thank you. Solid.
And you're just going to shade that blue.
And yeah, I'm shading everything that's on the inside of the V here all the way around. And so the solution is just this stuff here.